Excellent. Hi, I'm Dr. Marc Holmes, and today I'm going to give you an introduction to VR and what we've attempted here at the college and what you guys should be looking into if you haven't already started. So the College of Engineering is aiming to lead in its teaching methods, and one of those technologies we've been looking at is VR. And in recent years, the developments of HTC Vive and all these other applications and products which are coming out, we thought there might be a wealth of new learning capabilities. So we saw lots of videos like this coming out with people being able to move and handle things, experience, dodge and avoid what's going on in their real world. And we thought there might be potential here for learning. So over the course of last year, we ran lots of different experiments and trials to see how it worked, and we found a lot of benefit with the students. So VR itself is primarily worked around influencing sight, hearing, and to a small amount of touch. These are all the things which we can do in VR. We can share these informations and abilities via that, what do you call that, method for teaching. There are some combined senses which can be covered in VR, which are proprioception, which is basically the ability of your body to track, but it can be overridden with vision. And there's spatial awareness, which is a very powerful learning tool, because you can teach people to be aware of a space beforehand. So we'll jump into things which can't be done in VR right now. Inner ear rotation. So if you try and move people around in VR, it doesn't work very well. Heat requires physical devices to heat people. It also doesn't work. Pain is limited. Smell and taste is complex, and others. So right now we're limited to just those visions and sounds and a small amount of tactile sensation in VR. So I'm sure you may have guys seen lots of these different acronyms floating around, like what you call VW, VR, AR, MR, XR, RR. So what do these acronyms mean? So virtual worlds is the old one for referring to a three-dimensional environment created in computer graphics, normally viewed through a display. Technically, the virtual worlds which are being used in SANSA and our experiments are the same technology, they're just being viewed in a different way. Virtual reality, as augmented reality, is viewing information on overlay via what you call via a display normally. Virtual reality is the immersion where the world is indistinguishable from the real world, to the point that sometimes you have to be careful about leaving tables in scenes because people will lean on them. Mixed reality is where it's trying to combine the two. So there's I'm not sure if Danny talked about it, but there's a continuum between AR and VR. And this is, mixed reality is trying to be a mix between, where there's mixtures of things which are so real that you feel like they're almost there. XR is the term which you'll be finding people use these days, which is just to refer to all of these technologies, because every time anyone releases a new technology, they're trying to market it. So they keep coming up with new names and terms. So XR is the term you'll find for middleware products like Unity we'll talk about. So that's the mixed reality spectrum at the top. So real environments, overlaying information, which you call augmented virtual reality, and then virtual environments, and mixed reality is in between. So there we go. So what's those terms mean? So current hardware options, what you guys can do. So the old days, we used to have a CAVE here. CAVE is a very silly acronym because it's the first letter basically means the same word again and again. It's a recursive thing. That's what happens when you have computer scientists naming things. So it's an alternative virtual environment. It's 6 walls with a headset. They're very expensive. I think we spent, when we had our one, it was several £1 million to buy. It was old tech, it was expensive, but there was a lot of good info research done on them, and a lot of things which we're basing some of the stuff we do today about immersive learning, and which is called engineering design, was developed on these machines. So the research is useful, but the programs which there are have to be converted to run on new hardware. For a while, we tried doing stuff with 3D TVs. They were great for viewing 3D models. Internally, we did research on, so Webster did research on showing bones rotating, so try and help the students understand the shapes. But the problem is they're getting harder and harder to get now, but they're less commercially available. So we've been looking at new alternatives to using them. So the first one to look at is AR in 6 degrees of freedom. That means it can rotate and you can move around in space. So you can get this to run on mobile phones, and there's dedicated hardware more like the HoloLens and the Magic Leap, which make it more immersed, because rather than looking through a screen, you're looking through a pair of glasses into a virtual world. Way to use it is to build in video content. So like say you've got a poster, you want to have a video playing in there, you can add a little content to it, and then you can have that link which adds over on top of it. So you can also have 3D content come out of a poster, or 360 images. You can replace relative images. So we've got an example of Google Translate there running, converting which you call signs. You can view 3D models in place. So I'll show an example in a minute. And hidden layers of information. So on the far right there we have virtuoscope, which is being used to show like body parts in place. You wear a t-shirt and a tablet is aimed and you can see the body parts and move around it. So we'd use this initially for like crystal structures. So we have these posters which were made with these crystal structures, and you can just aim the phone at it and you can see the crystal structure. You can move the phone around and you can see the crystal structure from different places to try and help convey that complex three-dimensional information to the student. This is viewing in place. This is, you can see this one today. It's a landing gear, which is, we're talking about bringing down here. So it was placed in the hole, using the whole lens, and you could walk around and see it in place. And people talked about using it as a possible way of teaching various complex things to do with size, also to talk about how to look in and see how various parts come together, which you might miss if you're looking on a two-dimensional screen. So, VR 3 degrees of freedom. So this is like your Google Cardboards, your Oculus Go's, VR Gears, or if you guys know Pico 3D, some people use that one. So the main benefit of using this is for like 360 camera images work very well on this. So mono and stereo. Also can use pre-rendered environments. Its virtual worlds usage, unfortunately, is limited because you're limited to a mobile phone's level of power. So you're limited to what's called about 70,000 polygons, which isn't very much. So we have to be very cautious and very low polygon with our displays. We have been using this for spatial learning possibilities with our Oxford app, which is a pre-site tour. So it was used for zoology. They wanted to have a they wanted to be able to get the students aware of the site beforehand and aware afterwards to recall their memory. So Wendy has a poster of that in the main area, so I recommend seeing it, and you can go see the apps themselves down in the interactive area. We also found benefits for cooperative learning. If you see Terry Filer's presentation later, when we actually got one to be in VR and the other one to take notes and to ask questions. We found it worked quite well, two people working together, which also reduced the limits. We've tried doing a bring your own device policy with these things. So using Google Cardboard, people bring their own phones and drop them in. We find about 90% of people own a suitable smartphone, leaving 10% who need to have a device from us. And we found that unfortunately 70% of them use iPhones, which is unfortunate because iPhones are not really built for very good for Google Cardboards. They are got a low refresh rate, so you'll find it kind of a bit jerky as you move backwards and forwards, or they use the SE version, which is quite small. But there is something which we can do there, and we have run classes of it looking at Xavier, Dr. Xavier's app to do with construction. If you want to have a see, that one's available down there, and I think Xavier's giving her own talk later today. So these are like 360 images which are creatable. This is one taken from a drone, and we found these work great to give a sense of awe to the students, to get them into a place they wouldn't normally see. The 360 cameras are really cheap. So this is one which we normally use. It's like 150 quid. I think it's getting cheaper these days. And this creates a monosphere. There's a stereosphere cameras which create two views from two different positions. I haven't yet seen a benefit from using one, but we've found quite a lot of benefit from just having 360 images. We found that they're low pixel per radian. So basically, you have to be close to the image. You have to think of it like your eye, and you have to think of it as the person is short-sighted. So if you want to take a picture of something like this display here, you want the camera to be where you would be. You don't want it further away because you lose more and more information because there's less and less pixels. We find in early experiments that where we used to have the photographer in the photo, it just basically distracted from the learning goal. So what we would do is take two photos and use Photoshop just to remove that person. So that works quite well. We also found the height of the camera. So originally I used to take photos at my height, and people found that a little bit tall. And we tried taking photos at random heights, and people found them too low. We tried having them high up, and people felt like they were giants. We found 1.5 meters is just generally the right height. No one feels that they're too tall, and no one feels that they're too short, and it works very well. And as I said before, by taking these photos and pre-tours, we used that spatial awareness so people were aware of these site tours. There you go. So we talk on to room scale VR. So these are your Vives, your Vive Pros, your Oculus, and your mixed reality. We go on to them. So What can you do in them? So I recommend you come and see the apps which we have down the far end. We have an anatomy app where you build a skeleton. We've got access to the Santa space where our VR delegates are. Wave to them online. They are 3 or 4 of them online at the moment. The trench experience, which is about World War I, trying to have experience of what it would be like to be in a trench system. Inner space, a virtual museum built up of CT scans, objects blown up to larger than they would ever be. An antenna museum, so you can see invisible antenna shapes, the shapes of electromagnetic waves coming off antennas, and information about base campus construction, be able to see how the place was constructed and understand. So it's got some of these videos. So this one here is the virtual museum. This is a quick lightning tour of it. So basically you teleport around, you can handle objects, you can see videos, you can pick up objects, you can understand what's going on with them, you can see how they come together. So there's like, these are archaeological scans, and then there's other sections to do with biology. I'll just go away from that one. There we go. This is the build a skeleton. So we found lots of benefits. We've got another talk on this later, so I'll just skip ahead on this one. There we go. Other apps you might want to look at when you have your own time. Well, not even at your own time. Gravity Sketch is actually here today, so I recommend go seeing them. They're MB001. They have the tool in the middle of the man drawing the car. So basically that's a sketching tool. It's designed to be able to do quick prototype designs. You paint in 3D, and it becomes very quick and easy to come up with ideas. You can then use that in 3D content. You can also load in CAD models into it so that you can have a look at those and see how they work. I believe that Will and Pete are doing a talk on that later. There's other things you should have a look at, like VR Museum of Fine Arts, which is another museum which is very, high resolution? Body VR, which is a flying through cells, and Google Earth VR, which is scans of the world, and you can just fly around and see the place. So photogrammetry scanning is a technique which you can use with these things as enabling technology. So what we've done is we've scanned in places, rocks, other things, and added information to them, and these can be viewed. Sketchfab is a very good tool for this. They've now added lots of AR and VR tools, so you can click on view this model. So if you go down to the lab, you can ask to see this one. So to basically place it, and you can walk around it and see it from different angles. We also do this with our drone scans as well for scanning construction sites. So just talk about some of the added benefits of what you can do with VR than just taking into account the three-dimensional effects. Because you are using a computer, you can take into part computational education benefits. So instant feedback. You want to fail students faster, because the faster they learn that they're learning the wrong thing and they've gone down the wrong track, the sooner they can get on the right track. So this works great for things with definitive answers, like multiple choice, correct spell answers. Check whether they got, when I say area checker, make sure they put 2 objects roughly in the right location, or check their numbers in a mathematical equation. What it doesn't work very well for, unfortunately, is subjective answering, things which require reflection, things which require thought or explanation. If there's multiple ways to answer a question, they don't work very well. We have looked at machine learning for this possibility, but it has a lot of issues and a lot of bias. So right now, this is much better for definitive answers. The next part of computational education, which is beneficial, is flow theory. So based on your abilities of your skill and your challenge. So if you don't know a subject and you are thrown in the deep end, you find it anxiety, you find it overwhelming. If you know the subject very well and you're thrown into the basic courses, you find it boring. So by using flow theory and computational education, you can control the flow at which your student is going. You can either let them go faster, or you can, by basing on their answers, you can give them harder or easier tasks based on what they know. Whereas, unfortunately, like how I'm presenting to you guys right now, you guys are stuck in the same flow. So if you already knew, you find this either boring or anxious, depending on my speed. Another one to look into is the Tetris effect. So if you play Tetris for way too much, you'll end up dreaming of Tetris. The reason why is it builds into your procedural memory. This is a subconscious memory which you don't have control over. It's something which you learn, like in a way you know to navigate yourself home, even though you're not really thinking about it. This is something which you can take advantage of with VR and gamification, because they keep doing the task again and again, and they can learn the behavior. So if there's a certain sort of task you want them to learn off by heart and be able to do with instinct, this is a way to, by gamifying, this is a way to achieve it. Spaced repetition is basically bringing up information again and again over time to try and bring it to the forefront of their mind and make them forget it less and less. Now, you can also take into account competitive effects. So, for example, with the anatomy app, you can race against the clock. But then we have found an issue with this. The problem with global leaderboards is something called the superstar effect. And in the superstar effect, that's what used to be called the Tiger Wood effect. So basically, if you have somebody who is really, really good, everyone stops competing because there's no point of even trying. So we find it better to try and get them to compete against themselves so they can become their best selves rather than worry about trying to beat that A-star student at the front of the class. Oh, sorry. If you guys want to start doing this yourself, Unity 3D is a great tool. There's lots of courses online. It's got a GUI, so you can just grab and drag objects out. There's easily created 3D environments, and there's plenty on the asset store to buy, so you don't have to learn about 3D modeling. You can drag things out. And there's a virtual reality toolkit, which I highly recommend, which takes out all the issues about understanding Oculus, mixed reality, Vive. You just drag down the objects and the scripts. So my references. Oh, I got my references in the wrong order. There we go. And that's the end of my talk. So.
Thank you very much.
Yeah.
Okay. So now comes the interesting part of the conference for me, where I'm going to try to mediate the questions from the audience here, and we also have potentially questions coming online in the virtual room that reproduces this environment.
Yeah.
So I'll first start by taking questions from the room, if anybody has any for Marc today. Yes.
Hello.
Hi, Mark. Question I would have asked earlier in the first talk, but I think it's relevant to you. So we're on the third wave. Is there going to be a fourth wave, or are we here?
There will be a fourth wave, as recently stated by the Unity developer, the company who makes the 3D engine I recommend. They said that we've only really reached a developer level. So right now, when we ask our students how many have used VR, we get a 1 or 2% have actually used it. We haven't reached the point yet where you actually have most students have used VR and expect VR to be in classes. I feel that if you want to compare it to smartphones, we are in the compact phone days. I don't know if you guys remember them before the iPhone. So before the iPhone came out, there was Palm Pilots and compact phones, and they kind of did the features iPhones did, but they just didn't have it all together. So that consumer level VR kit hasn't come yet. And when it does, I expect we'll start seeing the student numbers drastically increase. I do believe if we keep using good middleware tools and open source platforms, we should be, in theory, be able to reuse the assets which we're creating now, and we can definitely use the theory which we're creating now when it actually comes. Okay. Is there any questions from the Sansa space?
No questions online at the moment.
Okay, thank you. Right. Oh,
Somebody over.
Yeah.
Okay.
Yeah.
Okay, most of the devices that are now used in schools are 3 degrees of freedom. We find that 6 degrees of freedom, of course, has many opportunities. How do you see, do you see 6 degrees of freedom being the only one that can really reach the max potential in VR, or there is a space for it?
So we found when we're doing our own testing that the 360 apps which we use, which are pretty much 360 sphere apps, are quite beneficial. But we find it difficult to keep anyone in 3 degrees of freedom for long because you feel it creates motion sickness because you move your head backwards and forwards and you don't experience that. There have been attempts to use the camera on the devices to give a small amount of 6 degrees of freedom for devices. You don't have the controllers, but you at least can move your head backwards and forwards. The 3 degrees of freedom, it's unfortunate because the position you're normally in is fixed. So you can't get that benefit of moving your head around an object to see it. And most people can't stand artificial locomotion. That's where you drive yourself around with a joystick. So I feel that the potential for 3 degrees of freedom is very limited, but there is stuff which you can do right now with it. And I do understand it being very cheap because Google Cardboard headsets are £5, and most people seem to own a $500 smartphone, so there is benefits. But I think if you want to get the most benefit, you're going to have to look at 6 degrees of freedom. But right now I understand the reason why people don't want to do that due to the cost.
Thank you.
That was sort of the, oh, yeah.
So with Vive and Oculus, you've obviously got this handset, you've got the headset. Do you see any sort of future, how do you think it's going to move in terms of that interaction, in terms of the tools you use?
So do I have some pictures of stuff? New coming hardware, there we go. So things which you'll see coming through soon. Santa Cruz is one on the far right. That's Oculus's new standalone headset. So it's like the Rift, except it doesn't need a PC. So that's something you'll see coming through, which is basically very similar. There's the Leap Motion, which is just launched, which is another HoloLens type. And then there's Pimax, which is like a Vive, but increased field of view. So and most of the stuff which you'll see will be continual upgrades, bigger fields of view, maybe more powerful computers, maybe more standalone-ish, maybe more of the same, but just slightly increasing the limits. What might be coming through is more hand tracking. There is a lot of research in that, but it hasn't yet come down to something which is actually usable. There's also work on spatial redirection. So one of the problems you might come across is in 6 degrees of freedom, you eventually hit a wall. These people think they're walking in a straight line or turning down a corridor, but they're actually being redirected by that wall they're touching. So there's a lot of research to try and overcome this issue. So people feel like they're actually walking for long distances in time, but they're actually going in circles. The other one which we'll probably see coming through soon is volumetric light fields. This is the kind of successor to 3D TV. So basically it's a kind of cube you can rotate, you can move yourself around and see the object in. So while this might be useful for sort of like viewing three-dimensional objects, it won't necessarily be for the sort of bridge crew experiments we've done with you before. Okay. Okay. Oh, there's one last. Do we have time for one more? Yeah. Okay.
Is any work being done on if people are immersed in the environment for a given amount of time?
Yeah.
On their return to the real environment, what's people's response if they feel VR when they come back into this space?
So there has been. I'm probably, unfortunately, if you can catch Dana, she's probably the one who would know much more about this than I do. I do know that there are issues sometimes with people becoming disorientated when they come back out of VR. The main issue I have, which I'm finding, is the interpupillary distance, the distance between your eyes. So people who try to use a headset which isn't set up for their distance of eyes for a long period of time can find it a bit disorientating once they come out. But I haven't read anything which is of long-term negative effect. It's normally a short-term benefit. I don't know if you guys know this, but you can actually cause your eyes to flip. There's a pair of glasses which a bunch of researchers made people wear, which flipped the world upside down. Within 2 days, they got used to it, and they saw the world normally again. They took the glasses off, and then 2 days afterwards, they could see the world normally again. Your eyes are very capable of changing to environments. So I haven't read any long-term negative effects, just short-term effects. But I recommend trying, if you catch Dana in a break, and let's see if she knows any more than I do on the subject. Okay.
Got time for a few more questions if you have any. There aren't any coming from online.
Okay.
Yeah.
Okay.
Not a question, it's more of a kind of initiating a dialogue, really. So I guess what you're saying is that VR is limited by how the human body interacts, and we can't augment the human body yet. And do you think that, because when we all had flip phones, we all thought they were really sophisticated, and then suddenly we had an iPhone, that was a paradigm shift, rather than that difference between horse-drawn and a car. And Henry Ford famously said, if someone asked me before I invented the car what they wanted, they would say they wanted a faster horse. And I guess, and do you feel that maybe the next stage of VR we can't really imagine yet?
So you're asking about the possible futures of the next generation. The very far next generation, which I've avoided putting any of that up here, is what would you call neural interfaces? So neural interfaces is being worked on, and that's matrix level technology. How it will actually work and how it will actually come is really, really very new. I'm not sure they work beyond. There's been some work like replacing people's human eyes with sensors to try and give blind people sight. There has been some work with trying to integrate cyborg sort of responses. The idea would be to have a full immersion where basically it's called deep dive, where you basically no longer perceive the real world and you are now in a completely virtual world, kind of like the hacker films you've seen from people seen in the last years. I don't know if we will ever see that, and if we ever did see it, I think there'll be such a paradigm shift to the way you even live our lives. But that's not realistic for what we're talking about now. I don't think we'll see that until probably 20 or 30 years, if anything we see in 20, 30 years on that.
Very good. We've got time for one final question,
Okay.
Very briefly.
Yeah.
Yes, please.
Yeah.
Probably hate me for this. Is
That's
there
all right.
a saturation point, Mark? When does it become too much? When is the novelty wear off?
There's some question which I'm worried about, and I do want to know the answer, because I want to. That's why I've been trying to focus on trying to make sure we get learning benefit, because at the moment I'm sure we're getting lots of novelty factor, and the students say it's very interesting and exciting, but whether they're actually going to keep going and keep using it is questionable. So I hope you go to our other talks today where we talk a bit more about the actual benefits we've detected and discovered from these things. So the anatomy app, massive benefit over book learning, and the other talks where we've talked about spatial benefits. How it's going to be used afterwards. I hope that from what we've shown today, when you guys will hope to go to the other talks and see, we'll be actually continue to use those spatial learning benefits, those computational learning. Whether we need to keeping it interesting, well, luckily it's using the realm of computer graphics, so we continually could change that up and make the places more interesting, more visually appealing, like movies and films do, to try and sell you basically the stories which you may have already heard, but in a different way, so we can focus on the learning objective we want to achieve. But we'll have to see how the novelty effect wears off, and unfortunately I can't predict it without more research. The people I've managed to wear it off on have been people who have actually been quite keen to use it, so I can't really say that's a good subset of people to actually test on.
Okay. Wonderful to see some really engaged audience. But we're going to stop the questions now, and if you've got any further questions, I'd like to invite you to come and talk to Mark after the session.
Yeah.
Thank you very much.